Hi everyone. My name is Dominic Tarr. I'm a mad scientist at Netform, and this is about streams, events, and data. So let's say we have an enormous JSON file. For example, the other day I downloaded all of the metadata for NPM. Actually, it's a few weeks old, so it's bigger now. And let's try and parse it. It didn't work. Seems when you try to parse too large, see that was we just loaded the file and then tried to parse the whole thing. It's like 500 megabytes. We tried to parse it and we got some really weird, ugly error message that doesn't even have a stack trace. So if you do want to parse everything in NPM, how do you do that? So you use a streaming parser. And that just starts to iterate over the file and pulls out the parts that just parses the parts that you need as you go and never loads the entire thing into memory at once. So it's just about as simple to do. You just open the file as a stream. You pipe it to this JSON stream module, and then you give the JSON stream module a path into the document that you're interested in. Now, NPM is stored in CouchDB, so this is the same format that it's just a CouchDB query. You can use this on CouchDB queries as well. And well, this works, the other way just doesn't work. Also has other benefits, such as you get to work with the output already. Notice when I ran the first one, the output stopped, did nothing for a few seconds, and this was immediately satisfying. At least I saw something. This is what we want. So streams are easy because they're all one small module that does one thing and published in NPM. You just install it and use it. There's less waiting, and you can do way more awesome stuff with them than waiting around, because waiting around is never fun. So you can make your own streams. This is using a module called through to make it easier to create the stream. So all you do is you call through, you pass it a function that reacts when a new piece of data comes into the stream, and then here we are transforming this. This is basically making the stream loud, so turning everything to uppercase. And then when the stream ends, it calls the second function, and we're just going to add another message to the end of the output, and then we're going to end the stream by calling qnull. There we go. It pipes into the through and comes output, and you'll see here we've piped the standard input into the stream and then the standard output. So a stream is to time as an array is to space. So you can imagine all of the familiar array functions. They can all apply to streams as well. So you can map a stream like we just did. You can reduce a stream. You can filter a stream. You can figure that out yourself or just install it from NPM. There's also, you might have heard of this thing called Streams 2, which is the new style of streams that's in Node 0.10. You can do exactly the same thing there. It's a little bit more complicated, where you call push instead of queue, and you have to call a callback to tell you when it's done. Now, there are a few differences between classic streams and new streams. They each have different edge cases optimized for different situations. For example, in Streams 2, it tries to concatenate all of the objects together if you don't read them out. So, and you have to set a thing called object mode explicitly. Whereas classic streams just work with objects. However, they're pretty much compatible if you just use pipe and implement a stream and then pipe one to the other. It's best to do it to access streams via pipe and not call the underlying methods like read read and write and end, except in extreme circumstances. Also, classic streams use pause and resume, and pause generally is stops the stream from emitting data, or tells it to try and stop emitting data. Some streams will promise to stop emitting data. Some streams just sort of do their best effort. But you can always pipe from a stream that does its best effort to one that promises to not emit data, and then you can pause strictly. But in streams 2, that happens by default. However, in streams 2, if you want to drop data on the floor, then if you don't care about the stuff, you have to call resume explicitly. So it's you'll win some and you'll lose some. But the principles are exactly the same, and that's the important thing. So there's a whole bunch of other types of streams as well. Gozella reducers are really interesting, and then these next two, Bacon.js and RxJS, are like streams for about organizing web, DOM events and stuff like that into streams for a thing called functional reactive programming. And I've experimented with this thing, pull stream, which is trying to be a maximally minimal stream. So with streams, we could do something useful like make yourself a DIY RPC protocol. So here we're just going to make a server that a client connects to it and then sends a message, and then with the timestamp in it, and then the server will just log that and then send a message back, and then the client can tell what the round trip time is. So we just start the server, start the client, and they can message each other. So you notice that the first ping is a lot longer than the others. It's because that's because the TCP connection was still forming in that time, so it had to do a handshake and so on like that. But then, this is on the same computer, so it's very very fast. But also, you'll notice this this function here that wraps the stream and turns a stream of data into a stream of JSON that's separated by new lines. So you can pipe any kind of JSON data through, and it will come out the other side as you hoped it would. So this is called the duplex pattern. You'll notice here, you take the stream, you take the IO stream, you pipe it to some kind of abstraction that has a stream interface, and then pipe it back to the IO stream. Now this is exactly like a telephone. You have one bit next to your mouth, and you pipe your voice into the telephone. It goes off to some other entity at the other end, and then another series of messages is piped back into your ear. And you'll see the server pattern, which is like there's an event emitter that takes a function that's an event listener that gets called with a stream, and then that's a new incoming connection, so that's like your phone ringing, and then you pipe it to something, and then it handles it. It doesn't have to be a server, strictly speaking, like an I/O server, but it just needs to be, you see this also with like an event emitter that sometimes a stream appears, and then you have to handle that in some way. So here's another module, dnode by Substack. So this gives you like sort of full strength RPC. You can do all kinds of crazy stuff, and you just pass an object with some functions on it into dnode. It creates a stream, and then you pipe it to the other side. And this other thing, this module I wrote called Scuttlebutt. This is kind of like a backbone model where it has the set function, and it where you can set a key and a value, and it emits change events and so on. And so it gives you basically a little in-memory key value store that you can pipe to a remote key value store. And when you change a key, in the background, it sends messages that update the other side. So it's for real-time data replication. It also works offline by default, just as in Jan's talk. So let's implement a simple chat room with this. So we're just going to pipe from standard input. We're going to split that into lines, and then we're going to pipe it into a stream that just adds it to the chat. So we're just going to set the chat where the key is the current time plus your name and the message that you said. And this is just we're going to export this and use this in the next module. So the server looks just like before. We just load the chat thing, we pipe it through chat. So we'll start the server. Start client. Client says hello. Server says hello. They send the messages to each other. If the client disconnects, then the client doesn't get the messages. But if the client reconnects, all the messages are resent again, so the client is now back in sync. But the real world is kind of messy. So what happens if someone tried to connect with the incorrect protocol? Say, for instance, HTTP. Can't handle that. So
can you clear the screen so you get a text on top? Perfect.
There you go. Cool. So we just need to handle the error. So the correct way to handle this error is when someone sends an invalid message, just log who they are and then kick them off. So stream.destroy is the way to do that. And this time, it just logged that it got this erroneous message from some malicious client, and the client was booted off immediately. That's what we want to happen. Also, there's another problem. Sometimes the server goes down. At the moment, if the server crashes, the server crashes, the client is just sort of transparently disconnected. That's not what we want to happen at all. So what we want to happen is, if the server crashes, we'll just disconnect and then reconnect later. So we can do that with this other module called reconnect. Basically, you notice here it looks kind of like a server. There's a function that returns a stream, and then that happens occasionally. The difference between this and a regular server is that this only connects to one point, instead of whereas a server accepts many incoming connections. So this is just like it will try to reconnect to that point. But the patterned interface feels rather like a server. It's really good to, when you're looking to try and design an API, just pick something that's really familiar, like something from Node Core or something like that, and then, or some well-known framework or API. It saves you, it's basically, the advantage it gives you there is you can reuse documentation. Like reusing code is good, but reusing documentation saves you really more time because you can say like, oh, it just looks like a server. And then people, if you keep in line with the expectations that people have for what a server should do, then it'll be pretty obvious how to use your thing as well. So this just tries to reconnect when the server goes down. So it's connected, it's trying to reconnect, it's connected, and you notice it slows down because, which is what you want. That's like, you know, that's what Gmail does. And messages come through. If the server goes down, I can still be typing messages that it will be sent when the server reconnects. This is just one piece of the puzzle that you'll need to implement, but it's a single streaming module, and then you can just use it with whatever other streaming modules you want to. Also, notice that we implement the abstractions that you're connecting together as a type of stream rather than like something that takes a stream. And then, so the RPC thing returns a stream, and then you pipe it to whatever you want, instead of you build a server or something and then pass the stream to the abstraction. It's much better to do it the other way, because, to do it the inside-out way, because then it will work with any kind of I/O. So you build an abstraction that doesn't do any I/O, then you attach it to some I/O. You can decide whatever kind of I/O you want to use. Unfortunately, there are these really popular protocols that don't do this, and that makes them hard to fit together. Like, it would be great to be able to just have your own SSH server and proxy it through other sorts of things, or and that's kind of hard to configure. Like, you can't use SSH over socket I/O or over WebSockets, because that's not built into the protocol, because the protocol is tightly coupled to the networking layer. The same with HTTP. Like, HTTP is just you have header, and then you have some framing, and that's all. But how come I can't store a file as HTTP? Maybe I just want to use the standard headers, standard header thing, and HTTP would be a great choice for that, because everybody knows it. Completely familiar with files, like, oh, it's just the files are, you know, it needs some metadata, it's an HTTP format, but it doesn't exist. Well, you could do this with Node, and I think there might be some Node modules for this, but this is how, moving forward, this is how we should do things. Socket I/O is another problematic one there, because it wraps a server, so you can only use it for WebSockets, but not TCP or Bluetooth or anything like that could also implement a streaming interface. So, just to recap, so the important things are through and duplex patterns. Those are the sort of streams you'll spend most of your time building in userland. The server pattern, of course, you'll see a bit, and then you'll just be building your application by plugging these parts that communicate with each other together, but you just hone the part really well, publish it on NPM, and then connect them together. So when you get into streams, there's this temptation to stream everything. And you probably go a bit overboard. We've experimented with streaming to DOM elements and this sort of stuff. With node streams, it was a little bit clumsy, but there are probably ways to do it. You probably don't need a streaming configuration loader. And templates are questionable because sometimes, like if you have deeply structured data, it doesn't really make sense to stream it. You're basically looking for things that are kind of like a list. There's like a series of things that happen, and you need to be able to consume the start of the data before the end. So for example, having a template for something like that was basically like one page of like all kinds of structured results doesn't really make sense. Streaming from a cache or streaming a file directly does make sense. Or if you have something like a news stream where you have a potentially infinite feed and infinite scrolling, that could be implemented well with the stream. Essentially what you're looking for is when your data is really an event. So here's a crazy idea. What about if instead of have a database, you had an event base? So we're working on this. There's this thing called LevelDB, and it's made by Google it's kind of like a NoSQL SQL Lite. It's just really simple. It has like 5 basic operations: get, put, delete, batch, and range, which allows you to query a range of keys. And the data is all sorted on disk. So it's sorted on disk, so you can read. And adjacent keys end up sequential. So when you read a series of adjacent keys, it's a single disk seek. So reading ranges of data is super fast. And it has some clever things that allow you to insert into the range. Well, it gives you the semantics of being able to insert in a range. So you can append to the database at any point, even in the middle. Which is really interesting because then you can represent a chunk of data, like a document, as a series of changes or events. So also, LevelDB is an embedded database. So unlike pretty much every other database, you can install it via NPM, and then you build it inside your application. So with other databases, you start a server, and then you connect to it and communicate with it via the database's API, which is pretty much set in stone, or at least mud that's so hard you're never going to stick your own sticks in it. But LevelDB you build inside your own server, and you can wrap around it. You wrap it with your own server in Node, so you can intercept everything that's going into the database and everything that's coming out. So you know exactly what's happening, and you can add all crazy extra features like that are great for real time and such like. So here's a few things I'm going to demonstrate. So say we just want to know when the database changes. So here we'll just create a database. We'll put a new record on it every second, and we'll just log the changes. So there's events coming out of our database. Of course, that's a very simple contrived example, and a bit ugly. Let's do it with streams. You notice here, I put some stuff in there earlier, and when you requested it, it gives you everything that currently exists, then it starts tailing. So you get back up to date, and then you get real-time feed. Now that's just as simple. You just create the live stream and pipe it to another stream. Now, since that's all embedded, so you can pipe that to an HTTP response, or to a file, or through WebSockets, whatever. That's up to you. Or say you could use that to replicate to another database. So here's a database. We're just randomly putting some data in it. And then here's another database that will connect to the first one, synchronize, and then take a live feed. If we disconnect for a little while and then connect again, it will sync the stuff since then and then carry on going in real time. There's a whole bunch of other modules for this that are really cool. If you get started, first place to start is the level module, and then the wikis. The wiki, Max Ogden wrote a binding for IndexedDB, which replicates the level down interface, which we can wrap into the level up interface, and then you get a working level DB in the web browser, in Chrome and Firefox at least. And then other stuff, Julian Gruber wrote multi-level, which is a client protocol. You can connect to it remotely and sequence and have multiple clients to one event, to one database with any sort of plugins you've had. This guy, M. Colina, he's turned up recently. He wrote a graph database on top of LevelDB. And I showed you this thing, showed you Scuttlebutt earlier. There's also a plugin that allows you to store scuttlebutts in LevelDB. Here's another crazy idea I've been working on. I wanted to see how simple could you make streams. So what if streams were just functions? So let's make a stream that reads an array. Let's call it values, pass it an array, and then return a function. Now this is pretty ordinary Node.js style asynchronous function. You call it repeatedly with a callback, and it gives you the next item off the array, and then it calls back with true in the error slot. Now I decided to make it like this. This is kind of breaking the rules because true isn't really an error, but in many cases for a stream, you handle an error and the end of the stream pretty much the same way. That an error means the stream is over, and so does the end. So then you have a reader stream, which is kind of like a writable stream, except it does the pulling. So you pass the writable stream, you pass the readable stream to it, and then it reads it. So it just calls a function repeatedly, and then does something. And if you tell it that you've ended, then it stops. You can also implement a map function a map stream really simply. So you have it's just a reader stream that when you pass it it's a reader stream that when you pass it a readable stream, it returns a new readable stream. So then you get 3 of those, and you can just compose them together by passing the results to each of the next one. So we create a value stream, and then we pass that to the map stream, and that returns another readable stream, and we pass that to the log stream, and it outputs 3 numbers. With a bit of higher order function tricks, we can give this a nice left to right readability. So we'll just I wrote this module pull stream, and you attach, you tell it what sort of stream each thing is, and then it wraps them and adds a pipe method. So you can just go values.pipemap.pipelog, and that's more the way I'm accustomed to looking at things. So that's a bit easier. And I've applied this to be an even crazier idea. jQuery is great. jQuery makes doing things really easy, but it only helps us in the browser. So what if, whereas on your computer, unless you're some Unix guy, you're always clicking on things and this sort of stuff. And Bash is really hard. I have to Google stuff just to figure out how to do an if statement in Bash. But what if it could be like jQuery? So jQuery is basically, you use a CSS selector to select some elements in a tree, and then you just apply some transformations to it what if we could do that with the file system? So we'll just use a glob, an extended glob, to select some files. Now this bit here is something I've made up, where ... means all of the parent directories from the current place. So it's like /, .. /, // etc., back down to /. And then the rest of it is as normal. So this is just going to traverse down to the root, and then select all of the package JSONs, and then we're going to read each file and parse it, and then we're going to map it to just the subset we're interested in, the name and the version, and then we're going to select the things that are unique by name, and then we're going to output it as JSON. And that, incidentally, are the modules you're able to require from this point. So I basically just wrote the module resolution function that require a node in 5 lines. So I'm just experimenting with this at the moment, but I have high hopes. Thanks. Any questions?
No questions? Robert, you want to go again? Did you get your phone yet? Really?
There's a question.
I'm going to go the long way around.
If you have an application that you don't expect to parse big files, do we really need to always thinking, why shouldn't I use streaming? Instead of thinking, if I need it, then I have to think about it?
Yeah, sure. Yep. But I mean, there's sometimes like where you might be, it turns out you will actually you were wrong, and you did need to load a really big thing. For example, one thing I used the other day was light table, which is really interesting looking for like the next generation of tools, thing. And I opened it. I set my dev directory so that this is where my projects are, and it went and traversed everything and froze for several seconds. Turns out that because of the way that Node installs things, it's pretty easy to end up with gigabytes of code in your local directory. Actually, this is an interesting point. So I'm not going to run the query thing, but you get. I had like 6. I got this computer in like December, and I've got 6 gigabytes of code that I've installed in my local dev folder already. So I didn't realize that until I tried to load it all with this text editor. And it didn't crash, but I mean, I shouldn't have to wait for 2 seconds for a computer to do something that's absurd.
How do you feel about promises?
Okay. They're not as cool as streams.
All right. Sorry, I had
Short
to
answer.
ask.
Yep.
So what exactly then is the difference? It seems to me, and I've been told that this is not the case, but it seems like streams are just promises that can kind of have multiple events, whereas promises are either accepted or rejected.
I would prefer to say that promises are just streams that only have one element.
All right. Yeah. That seems fair enough.
Yeah.
Thank you.
Similar, but the fact that you can have multiple gives you a lot more things that can happen than streams allow you to do totally new things that just doing with callbacks would be awkward. Yeah.
Thank you.
Okay. This one. I'm gonna go the long way again. So I feel obliged to point out that promises are actually way cooler than streams, because promises are monads.
Streams are monads too.
Hi,
Schrodinger's cat is a monad.
Hello, my name is Chris. With your JSON pass,
Yep.
was it? Or JSON stream?
JSON stream.
Can you keep track of where you are in the stream so next time you can just start from there, or do you have to read the whole stream again?
That would be an interesting pull request.
Thank you.
Or just put that stuff in a database.
Okay.
Yeah.
Just a follow-up question to my question. So you're saying that we should always, unless we control the data, use streams in case they grow larger than we have anticipated?
I wouldn't. One of my most strongly held beliefs is never say never and never say always, but consider that it may be. It's worth considering.
Yeah, at least
Yeah.
I can think about it.
Yeah, think about it at least. Yeah. Oh, often on the promises thing, often if you're trying to get out of callback hell, streams also get you out of callback hell because you get this linear flow instead of callback. So that's good too.
Is that it?
Cool. Thanks very much. Oh, do I have